Okay, so the next test here, follow me and write along with me. Test 2.1B, I think, and this will be under exercise. Okay, exercise 2.1. This will include questions B, 2.1B, 2 and 3. B, 2 and 3. We'll find this on the textbook, page 35. Okay, so follow me and write it likewise along with me. Let me read the question for us. Number B2. Write the coefficients of x squared in each of the following. So we have to write the coefficients of x squared. So in each of these followings, in question number B2, start with subheading 1. So given to us here in B1, B2 subheading 1 is 2 plus x squared plus x. And now in the previous class we have learned that coefficient means the one in front, right? So therefore I write here coefficient of x squared. That's what the question is asking. In this case is to find the term having x squared, and it is this one. So whatever is in front covered at x squared, and in front nothing is there. That means the number is 1 and plus sign, so it is 1 plus 1. So the answer is coefficient of x squared in 2 plus x squared plus x is plus 1 in front of the factor in front of x squared. Okay, so second one, B2 subheading 2. 2 minus x squared, okay, plus x cubed. So like we have done previously, therefore coefficient of x squared in this case is, let us find where x squared is in this expression. Which term is it? Second term, this one. So in front of x squared is here minus, means no number, means the number is 1. So minus 1 is the coefficient of x squared in the second polynomial. The third one here, pi by okay, given. You can write here given if you want, and then here also given to us, therefore pi by 2x square plus x, this much only. So in this polynomial, the coefficient of x squared here is, here x squared in front, whatever it is pi plus pi by 2. No sign written means we read it as plus, right? Plus pi by 2. So this is the third answer. Then one more, fourth one. So fourth one is root 2x minus 1. So okay, given, let us write down given. Given is root 2x minus 1. Well, the question is saying find the coefficient of x squared, and there is no x squared visible, or there is no x squared in this expression, so we have to create it ourselves. So we can create it. You can write like this, root 2x minus 1, just write same, then plus, we can write like that, right? 0. Anything can be added to 0. 4 we can write as 4 plus 0, because 4 plus 0 is 4 itself, so I can just add 0 and it doesn't affect. Then we can write here that is root 2x. This expression can be expressed as minus 1 plus 0, means I can write here 0 into x squared, because 0 multiplied to anything will come out 0. X squared into 0, finally will come out 0. That way we are creating an x squared, a term containing x squared, because in the original polynomial there is no term having x squared, and the problem is the question is asking the coefficient of x squared, right? And since there is no x squared, we created ourselves by putting 0 plus 0 and multiplying that 0 to x squared, so creating the x squared ourselves. Now we can answer our question. Therefore, in this case, coefficient of x squared here is very clearly in front of x squared is 0, so 0. I hope you're getting right. So next, B3. Okay, B3. Okay, B3. So question B3. Let me read the question for us. Give one example each of a binomial, we have learned this binomial of degree 35 and a monomial of degree 100. So I can write here. Give an example. So an example. Okay, an example of a binomial. So this is important keyword, a keyword here, binomial of degree 35 is anyone we can choose. There's so many we can write. Okay, so here an example of a binomial of degree 35 is the highest power of the variable should be 35. So let me just write here 7 into x, let us say variable is x to the power 35. So the highest power of the variable should not exceed 35 because the degree means the highest power of the variable. So there should be no x power higher than 35. But they're saying binomial means there should be two terms. So you can put plus also or minus also, whatever you like. Then you can write here anything 5, 35, whatever number you like. And if you can leave it like that. And then it has got two terms, right? So this can be your answer. Or if you want, you can put here x also, 35, and any power of x lesser than 35 you can put square or x to the power 30, but it should be lower than the highest power 35 because we are required to have the degree as 35, not exceeding 35. So this can be one, or so many. This can be your answer. Or you can write x to the power 35 minus 7, two terms, means binomial. Highest power 35 means degree 35. So there are innumerable number of examples that you can give for a binomial of degree 35. Okay, so what I mean to say here is that what example you give in this case may not be same, may or may not be same to the example that another person chooses. So, and that's fine because the answer is correct. So next one is an example, another example they're asking. An example of, look into your text, an example of a monomial, this time a monomial. We know in the previous class we have learned that binomial means contains two terms like this. Monomial means only one term. So monomial of degree 100 is, so many we can give. So we can write here 2x, if you want to put x, or y also you can put any variable. So degree 100 means the variable should have a power of 100. That can be your answer. Or you can write here 3x to the power 100 or 5y to the power 100. So many can come out. Okay, so your answer is not going to be same. Most probably is not going to be the same as the answer that your other friend chooses, even though both of you are correct. Monomial means only one term. So only one term. So I cannot be writing 2x to the power 100 plus 5x. That will become binomial again, two terms. Right. So these are the two examples, and then 2 and 3 is done. So that concludes the part 4, Test 2.1B. I hope you got it right.